Hey chemists, in this video we're going to look at some common organic reactions. It's a really short lesson that just looks at examples of the kinds of reactions that we see in organic chemistry. Very short list, not comprehensive at all, but some common ones you might see in this level of the class. On your notes is a description of a different batch of reactions. We've got 8 of them here, and we're just going to play a matching game to see if we can figure out from that list which one down below goes with the reaction up above. We've got a substitution, an addition, esterification, combustion, saponification, fermentation, polymerizations of addition, and condensation type, and those descriptions are there. So let's look at each one. I'll do the first few and then ask you to hit pause and see if you can do the rest on your own. The first one, this is a representation of a glucose molecule. There's glucose written out. It says it reacts with yeast. This is actually a catalyst, and it makes unbalanced some carbon dioxides and ethanol molecules. This, if you can't tell from the description up above, which directly says glucose reacts with yeast, this is an example of a fermentation. So I'm going to just write fermentation. This is how sugars turn into alcohols and gaseous carbon dioxide. We ferment sugars when we make bread, and this is the rising agent. Obviously, there's also folks in the spirits industry that use this for making ethanol. B shows an example of an alkene reacting with a chlorine molecule, and the pi bond goes away to give all sigma bonds in this 1,2-dichloroethane molecule. This is an example of an addition reaction. An alkene reacts with a small molecule to make a substituted hydrocarbon. It doesn't have to be chlorine. There's a variety of small molecules where they add one group to one carbon and one group to the other to give you a substituted hydrocarbon. C shows an example of an ester. Go back to your functional group notes. That's reacting with a base, hydroxide, to make an alcohol, and the conjugate base of a carboxylic acid, what's called a carboxylate. And if I find the best description up above, that is a saponification. An ester reacts with hydroxide to make an alcohol and a carboxylate. This is the main chemistry found in soap making, saponification. Soaps are made from esters, and they turn into larger carboxylate species that are good for dissolving both polar and nonpolar things. Next, reaction D shows 3 identical amino acids. That's a functional group that has a carboxylic acid and an amine in the same molecule. We lose water and we create a much larger molecule, likely much more than just 3 of them. This thing keeps going in a long chain. And you can see where the water comes from. If you imagine one of these hydrogens on the nitrogen combining with the OH of the acid, that's where you lose a water molecule from each one. I'll actually box that out on each side. And then you end up forming a bond between the nitrogen and the carbon-oxygen double bond on the other side in both cases. If you look up above, this is an example of a polymerization. Specifically, this is called a condensation polymerization, meaning you lose water, you condense. So there's the first 4. I'd like you to hit pause and see if you can figure out the last 4 based on the descriptions up above. What do you notice about how we would best classify those remaining 4 reactions? Okay, welcome back. If you want to check, E is a hydrocarbon plus a small molecule where one of the hydrogens is replaced with an atom from the small molecule. This is called a substitution reaction. It's descriptive because you substitute a hydrogen for a different atom. In this case, an H becomes a bromine. F is another polymerization. You don't lose anything, though. You form new bonds between the carbon atoms in a sequence, and you make a polymer. In this case, this is Teflon, but this is an addition polymerization. Because they add to each other, you're not losing anything, so this is not a condensation. This is how we make most of the plastics that you've ever heard of. You take things like alkenes, and you attach them to each other in a long chain, and the properties of the polymer are based on whatever atoms are attached to that group. Oh, this actually is not Teflon because it's not completely fluorinated, but it is a perfluorinated polymer. Teflon, I believe, is if every single atom is a fluorine. G is a structural representation of a combustion. This should have been the easiest one to identify. That's just oxidation of a hydrocarbon to make CO2 and water, which by process of elimination, you could tell hopefully that the last one is esterification. That's the name given when we make an ester. And we get that from doing a dehydration of a carboxylic acid and an alcohol. This is also a condensation. You lose the OH, the H from the acid and alcohol respectively. That's where your water molecule comes from, and that oxygen gets attached to that carbon, and that's how you get that new ester bond right there between the carbon and the oxygen. So that's how we can identify some reactions and just the common names that are given to some of the reactions that we see in organic chemistry.